Today we will be talking about the current source circuit, how they work and how they are useful in a multitude of electrical circuits. We will explain these concepts using real-world analogies. Normally, to control current in a circuit, a resistor will be used, and they will act according to Ohm's law, which relates current to voltage divided by resistance. However, resistors are difficult to implement on ICs, and are sometimes impossible to manufacture due to the size constraints. So we use current mirrors and current sources to properly bias amplifiers on an integrated circuit. A current mirror, as the name suggests, mirrors the current flowing in the left channel onto the right channel. The current on the left side to be mirrored is called the reference current. But before we get into the details of how a current mirror source actually works, we need to know how a transistor works. As we've seen before with the famous water analogy, the bipolar junction transistor can be modeled with the following diagram. Imagine that the flow of water is the electrical current. As the water flows into the valve, it pushes up against the plug, allowing the larger flow of water to commence from the top. This effectively acts as an amplifier, since we are creating a large amount of current from a relatively small source. Note how a little bit of flow from the input joins the larger stream of water. This is very similar to how a real bipolar junction transistor works. The base current is added to the collector current, which is then outputted through the emitter. When we put two identical BJTs in the following configuration, by connecting the bases together, we create a simple current mirror. When a DC current is applied to the left transistor's collector, it becomes the reference current. Watch what happens to the current on the right transistor. A little bit of current flows to the base connection, and since we have identical transistors, the current is equally divided and injected into the bases. So the reference transistor turns on and lets some current pass through. Remember that the sum of twice the base current and the collector current is equal to the reference current that we want mirrored. The base current acting on the second transistor allows an almost equal amount of current to flow through it. This is how the current is mirrored. Through this process, we can replicate the reference current at various points in the circuit. This is known as current steering.
We now consider the basic MOSFET current mirror, which follows the same principles of the BJT current mirror, but uses two field effect transistors instead. Voltage is analogous to water pressure in our example, so we have a pressure-activated water valve to serve as a model. At the reference transistor, the drain current is equivalent to the reference current because a field effect transistor does not draw any current through its gate. This means that the output current of a MOS current source will be closer to the reference current than a circuit that implements BJTs with a finite beta. Both of the FETs are operating in saturation mode. This means that there is a constant potential applied across them. The drain current of a MOSFET is a function of both gate source voltage and the gate drain voltage. Of course, for a current mirror to function, it needs a reference current. This is set by attaching an appropriate size resistor to the collector or drain of the reference transistor. As we mentioned at the beginning, current mirrors are essential in integrated circuit design when a constant current is required regardless of voltage. We also see the circuit heavily utilized as a constant load in differential pair amplifiers. There are many variations of current source circuits that optimize the behavior for certain applications, but we have seen the most basic designs and how they function.